It is a common experience that when a liquid is heated, it expands irrespective of the temperature range. However, water is an exception. When water at 0 degrees Celsius is heated, it contracts till 4 degrees Celsius instead of expanding. On further heating from 4 degrees Celsius, water expands like other liquids do. The special behavior of water between 0 degrees Celsius and 4 degrees Celsius is called the anomalous behavior of water. In the year 1805, the scientist T.C. Hope devised a simple arrangement known as Hope's apparatus to demonstrate the anomalous behavior of water. Hope's apparatus consists of a long cylindrical jar with 2 openings on the side, one near the top and the other near the bottom, to fit thermometers in each of these openings. A metallic cylindrical airtight trough with an outlet is also fitted onto the jar on its central portion. 2 thermometers are fitted airtight in the 2 openings of the cylindrical jar. Let us label the thermometer near the bottom of the jar as T1 and the one near the top of the jar as T2. Now the cylindrical jar is filled with water. The cylindrical trough at the central portion of the jar is filled with a freezing mixture of ice and common salt. Initially, both the thermometers show the same reading, say 12 degrees Celsius. As the trough is filled with the freezing mixture, the water in the central portion of the jar loses heat energy and gets cooled. Its volume decreases and density increases. As a result, the denser layers of water in the central portion move downwards, displacing the lighter layers of water there towards the central portion. This forms a convection of water. Due to this convection, thermometer T1 near the bottom shows a rapid fall in temperature till it reaches 4 degrees Celsius. At 4 degrees Celsius, the density of the water in this part of the jar is maximum. Thus, the dense water remains in the lower portion. However, the temperature recorded by thermometer T2 remains almost unchanged. Now, the water in the central portion of the jar cools to below 4 degrees Celsius. Due to the anomalous expansion of water, it begins to expand. As the volume of the water increases, its density decreases. As a result, it moves upwards. Thus, thermometer T2 shows a rapid fall in temperature. However, the temperature of water in the lower portion of the cylinder remains at 4 degrees Celsius. The temperature of water in the upper portion of the jar continues to decrease gradually below 4 degrees Celsius. As the temperature of water decreases from 4 degrees Celsius to 0 degrees Celsius, it expands and its density decreases. Hence, the cold water rises to the surface and forms a thin layer of ice. The ice floating on the surface of water indicates that the density of ice is less than the density of water at 4 degrees Celsius. The temperature in thermometer T1 remains at 4 degrees Celsius, while that in thermometer T2 falls to 0 degrees Celsius. This is due to the anomalous behavior of water. If you plot a graph for the variation of the temperature recorded by thermometer T1 with time, it will be as shown here. Similarly, the graph for the temperature recorded by thermometer T2 with time will be as shown.